Namaste children. Let us continue with congruence of triangles. We studied that two triangles are congruent by the rules SSS criterion, SAS criterion, ASA criterion. Here the symbol A stands for angle, S stands for sides. If three sides of a triangle are correspondingly equal to the three sides of the other triangle, then we say that those two triangles are congruent. If in any two triangles, two sides correspondingly equal to the two sides of another triangle and the included angle, here we say that these two triangles are congruent if AB and BC are equal to correspondingly DE and EF, and the included angle B is equal angle E in this triangle, then we say that SAS criteria. In ASA, angle, side, angle, angle, side, angle, angle, side, angle. In these two triangles, BC is equal to EF and angle B is equal to angle E, angle C is equal to angle F. Then we say that these two triangles are congruent. Here, side BC is correspondingly equal to side EF. And the included angles means the angles formed at the end points of these two sides, and these end points are called vertices of the triangle ABC, and these two end points are here called vertices of the triangle DEF. These two included angles are equal to corresponding included angles. Corresponding means side BC is equal to side EF. Therefore, the angles formed at the end points or the vertices B and C are correspondingly equal to the vertices E and F. Then we say that triangle ABC is congruent to triangle DEF. So here is one example in the textbook. What it reads: by applying ASA congruence rule, it is to be established that triangle ABC is congruent to triangle QRP, and it is given that BC is equal to RP. What additional information it needs to establish the congruence? Here he explains very nicely. For ASA congruence rule, we need the two angles between which the two sides BC and RP are included. So the additional information is as follows. Angle B is equal to angle R, angle C is equal to angle P. ASA rule. Here, ABC QRP and BC is equal to RP. Here they named this as QRP. Instead of DEF, let us name the triangle as QRP. BC is equal to RP. BC is equal to RP. Angle B should be equal to angle R. Angle C should be equal to angle P. Angle B should be equal to angle R. And angle C should be equal to angle P. Or if DBC is equal to EF, we can write angle B is equal to angle E and angle C is equal to angle F. Naming the vertices is important. Now the example 7. In this figure 7.26, can you use ASA congruence rule and conclude that triangle AOC is congruent to triangle BOD? Here, in the two triangles AOC and BOD, angle C is equal to angle D. It is given is equal to 70 degrees. Also, angle AOC is equal to angle BOD. Here, AOC is equal to angle BOD. They are vertically opposite angles. They are formed at the vertex O in opposite direction. So, angle A of triangle AOC is equal to 180 minus this triangle. Consider this triangle AOC. In this triangle, by angle sum property, sum of all the three angles is equal to 180 degrees. Therefore, this angle A is equal to 180 minus sum of these two angles. Sum of these two angles is 100. And if you subtract 100 from 180, you will get 70 degree. By using angle sum property, we can write angle A is equal to 80 degrees. 70 plus 30 degrees is 100. 180 minus 100 is 80 degrees. Similarly, angle B is equal to 180 minus 100. It is 80. This is 30 degree and this is 70 degree. In triangle BOD, by angle sum property, this angle B is equal to 180 minus sum of these two. Sum of these two is 100. 180 minus 100 is 80. Therefore, angle A is equal to angle B. Thus, we have angle A is equal to angle B. AC is equal to BD given. Angle C is equal to angle D. Here, one side AC, another side BD in the another triangle. Corresponding included angles are angle A is equal to angle B, angle C is equal to angle D. Therefore, these two triangles are congruent. Now, let us study RHS rule. Here, specifically we take right angled triangle. These two are right angled triangles A, B, C, D, E, F. Right angled at B and E respectively. If under correspondence, one hypotenuse, we know that the side opposite to right angle, this is the side opposite to right angle, is called hypotenuse. In this triangle ABC, AC is the hypotenuse. In this triangle DEF, DF is the hypotenuse. If in these two right angle triangle under correspondence, hypotenuse of one triangle and one side of the triangle, hypotenuse and one side of one triangle correspondingly equal to hypotenuse and the one side of the another triangle, then we say that these two triangles are congruent. If in two right angle triangles, if under correspondence, the hypotenuse and one side of a right angle triangle are respectively equal to the hypotenuse and one side of another right angle triangle, then the triangles are congruent. We say this as RHS rule. Why call this as RHS rule? Because R stands for right angle, H stands for hypotenuse, S stands for one side. Example 8. Given below are measurements of some parts of two triangles. Examine whether the two triangles are congruent or not using RHS congruence rule. In the case of congruent triangles, write the result in symbolic form. The measurements of triangle ABC and measurements of triangle PQR are given. First one, angle B is equal to 90 degree, AC is equal to 8 centimeters, AB is equal to 3 centimeters. In triangle PQR, angle P is equal to 90 degree, PR is equal to 3 centimeter, QR is equal to 8 centimeter. Here they have drawn the triangles. First one, angle B is equal to angle P is equal to 90 degree. Here he has drawn two right angle triangle, right angled at P and B. Hypotenuse AC 8 centimeter and RQ 8 centimeter. These two sides are opposite to right angle and they are called hypotenuse and they are equal. and one side RP is equal to AB equal to 3 centimeters. Therefore, triangle ABC is congruent to triangle RPQ. Writing the order of the vertices is important. How we write the congruency symbolically? Triangle ABC is congruent to triangle RPQ. Similarly, second measurements. According to second measurements, he has drawn the two figures like this. Angle A is equal to 90 degree. Angle Q is equal to 90 degree. And AC is equal to 5 centimeter. AC is equal to 5 centimeter. BC is equal to 9 centimeter. PR is equal to 8 centimeter. QP is equal to 5 centimeter. In these two sides, triangles, one side is equal. But what about the hypotenuse? What is the hypotenuse here? The side opposite to the angle A is BC. And the side opposite to angle Q, right angle, is RP. Are they equal? 9 centimeter is not equal to 8 centimeter. Because the hypotenuse are not equal, we can say these two triangles are not congruent. Now the example 9. Here, read the question carefully. In figure 7.31, this is the figure 7.31. DA perpendicular AB. This sign stands for perpendicular. Perpendicular means the angle between the two lines where they intersect each other. At that point, right angle is formed. Therefore, we say that DA perpendicular AB, comma, CB perpendicular AB. DA perpendicular AB. CB perpendicular AB. State the three pairs of equal parts in triangle ABC and triangle DAB. Which of the following statements is meaningful? Triangle ABC is congruent to triangle BAD. Symbolically, we should write the corresponding parts. The three pairs of equal parts are angle ABC is equal to angle BAD. Angle ABC is equal to angle BAD in these two triangles ADB and ACB. AC is equal to BD. AC is equal to BD. It is given. This sign symbolizes equality of these two sides. Given that AC is equal to BD here. AC is equal to BD. AB is equal to BA, common side. AB is equal to BA. Why we write AB is equal to BA? Why we didn't write AB is equal to AB? Because angle A is equal to angle B is equal to 90 degrees. Therefore, AB is equal to BA. What is the condition? If under correspondence. This is called correspondence. The three pairs here are one angle, one side, and another side. One side is hypotenuse. Being right angle triangle ABD and BAC. These two are right angle triangle and DB is hypotenuse in this triangle. AC is hypotenuse in this triangle. Therefore, hypotenuse, side and angle. Right angle. By RHS rule, we say that triangle ABC is congruent to triangle BAD is meaningful. Why? A corresponds to B. Vertex A corresponds to B and B corresponds to A. B corresponds to A and C corresponds to D. Therefore, this is meaningful. Statement A is meaningful. Statement B is not meaningful in the sense that the correspondence among the vertices is not satisfied. Correspondence among the vertices should be satisfied. Then let us start with exercise 7.2. congruence criterion do you see in the following? First main A. Given AC is equal to DF, BC is equal to EF, AB is equal to DE, AB is equal to DE. In these two triangles, all the sides are equal. So, triangle ABC is congruent to triangle DEF. Here, yes, congruency. What we should write? Yes, congruency criterion. Now in the second one, Zx is equal to Rp. Zx is equal to Rp. Rq is equal to Zy. And angle PRQ is equal to angle XZY. These two sides are equal and the included angle formed by these two sides is called included angle, and these two included angles are equal. Therefore, PQR is congruent to triangle XYZ by SAS rule. What we should write? SAS congruency criterion. Then the third one. C. M, L, N, G, F, H. M, L, N is equal to F, G, H. This one. This angle is equal to this angle. N, M, L is equal to G, F, H. N, M, L. This angle is equal to G, F, H. G, F, H. And ML is equal to FG, this side. One side and the included angles. What is that criterion? ASA. We should write the answer as ASA congruency criterion. Now the fourth one. EB, DB. Side EB is equal to DB. Do you observe, children? These two triangles are right angle triangle. This symbol, this square symbol symbolizes angle A is equal to 90 degree, angle C is equal to 90 degree in these two triangles. So we have right angle triangle, and EB is called hypotenuse of the triangle EAB because A is right angle and the opposite side is EB is called hypotenuse. In this triangle, DB is hypotenuse because it is the side opposite to angle right angle C. These two hypotenuse are equal. EB is equal to DB given. AE is equal to BC. AE is equal to BC, one side. Here the vertices should be in correspondence. What are the vertices that are in correspondence? Angle A is equal to angle C. Therefore, vertex A corresponds to vertex C and vertex B corresponds to vertex D because vertex E corresponds to vertex B. B corresponds to D here. In this triangle EAB, B corresponds to D because AEB is equal to DB. EB is equal to DB. Therefore, B corresponds to D. B corresponds to D and E corresponds to B. E corresponds to B. In this B is from this triangle. Let me draw the figures separately so that you will understand. This is E, A, B, B, C, D. EB corresponds to DB, angle A is equal to angle C, and EA corresponds to BC. EA corresponds to BC and EB corresponds to DB. This is the side. We should write like this. They have end points. That is why. EA corresponds to BD. EA corresponds to BC. EA corresponds to BC because these two sides are equal. A corresponds to C. Therefore, EA corresponds to BC. EA, BC. This angle is equal to this angle. Therefore, A corresponds to C. That is, A corresponds to C and B in this triangle corresponds to D in this triangle and E corresponds to B in this triangle. Did you understand? Is it clear? If you don't understand, if you have any doubt, you please ask me in the comment box. I will explain it. In these two triangles, don't be confused. There is no confusion here. We should see the corresponding angles and sides. Angle A is equal to angle C. Therefore, vertex A corresponds to vertex C. Why B corresponds? In this triangle, this point B. This vertex B corresponds to D here. BE equal to BD. And it is the point or the vertex connected to this right angle. B corresponds in this triangle. B corresponds to vertex D in this triangle. We should write E triangle A B E is corresponds to or congruent to triangle C D B. Now the second question. What it reads? You want to show that triangle ART PEN and you are to use SAS criterion. First one, for SAS criterion, what we should need? First one is SSS. SSS congruence. If you have to use, see, this is the question. Second main, you want to show that triangle ART is congruent to triangle PEN. These two triangles are drawn here in the textbook. And the first question A, if you have to use SSS criterion, then you need to show that. What are the conditions for SSS criterion? All the three sides should be equal to the other triangle under correspondence. That is, if you have to use SSS criterion, then you need to show that AR is equal to triangle ART congruent to triangle PEN. ART congruent to triangle PEN if AR is equal to PE, RT is equal to EN. Then the third one, AT is equal to PN. Here, AR is equal to PE, AR is equal to PE, and RT is equal to EN, and AT is equal to PE. This is how you should write the congruence under correspondence. Now the second one. If it is given that, what is given? Angle T is equal to angle N. Here angle T is equal to angle N. You need to have RT is equal to, RT should be EN, and PN is equal to AT. Did you understand? They should be congruent. Which order? Triangle ART is congruent to triangle PEN. Triangle ART is congruent to triangle PEN. Triangle ART is congruent to triangle PEN. Here angle T is equal to angle N, and RT should be equal to EN, and PN should be equal to AT. Now the C. If it is given that AT is equal to PN, you are to use ASA criterion. For ASA, this is for SAS criterion, and this is for ASA criterion. You need to have, what should be the conditions? ASA criterion. AT is equal to PN. AT is equal to PN. The included angles will be angle T, angle A in this triangle, angle N and angle P in this triangle. The included angle for the side AT is angle A and angle T. For PN is angle P and angle N. The condition should be angle A is equal to angle P, and the second one is angle T is equal to angle N. Therefore, triangle ART is congruent to triangle PEN. Angle A is equal to angle P. Here, angle A is equal to angle P. Angle T is equal to angle N. Angle T is equal to angle N. AT is equal to PN given. Now the third one. You have to show that triangle AMP is congruent to triangle AMQ. AMP is congruent to triangle AMQ. In the following proof, supply the missing reasons. Steps. What are the steps? PM is equal to QM. PM is equal to QM. Writing the order is very, very important. Here M corresponds to M, A corresponds to A, P corresponds to Q. Therefore, AMP is congruent to AMQ. PM is equal to QM, given. It is given here. The symbol written here indicates these two sides are equal. It is given. Reason should be given. Without reason, your answer is incomplete. Angle PMA is equal to angle QMA. PMA is equal to, this one. PMA is equal to QMA. This is also given. This symbol indicates these two angles are equal. And it is given here. In this figure, it is given. You should write given. Third one, AM is equal to AM, common side. Therefore, these two triangles are congruent by SAS rule. What we should fill the blanks here? Third one, reasons. First one, given. Second one is also given. Third one is common side. Means it is common to both the triangles by two sides and one angle. One angle is included angle. SAS criterion. This is how you should write the answer. Now the fourth one. In triangle ABC, angle A is equal to angle 30, angle B is equal to angle 40, angle C is equal to 110. In triangle PQR, angle P is 30, angle Q is 40 and angle R is 110 degrees. A student says that triangle ABC is congruent to triangle PQR by AAA congruence criteria. Is he justified? Why or why not? No, he is not justified. I'll explain you. This is the fourth one. Now I can draw the figure like this. In these two triangles, this angle is 110. This angle is 30 degrees. This angle is 40 degrees. And this angle is also 110 degrees. This angle is also 30 degrees. This angle is also 40 degrees. But they are not congruent. Because we can have a triangle which is bigger in size. Though same shape, but it is bigger in size. This triangle is also having same measurements of angles. But they are having same shape, but of not same size. We cannot say they are congruent. They look similar, but they are not congruent. Congruency means Xerox copy, superposition. If you keep this triangle on this triangle, they should be superposed. But here it is not possible. Therefore, we say that these two triangles are not congruent. A, B, C, D, E, F. A, B, C and triangle D, E, F are not congruent. Now the fifth one. Here the figure is given that see this figure. In the figure, two triangles are congruent. The corresponding parts are marked. We can write triangle RAT is congruent to. Let me explain with the diagrams. R T A N O W. RT is equal to RA is equal to WO. This one. AT is equal to NO. AT is equal to NO. Angle A is equal to angle O. Angle W is equal to angle R. Angle R is equal to angle W. And angle T is equal to angle N. Angle T is equal to angle T is equal to angle N. This one. Angle R is equal to angle W. Angle R is equal to angle W. In these two triangles, angle A is equal to angle O. Therefore, A corresponds to O. And angle R is equal to angle W. Here, this angle R is equal to angle W. So, these two vertices are corresponding. And angle T is corresponding to N. Triangle RAT is congruent to R corresponds to W, A corresponds to O, T corresponds to N. Triangle RAT is congruent to triangle WON. Now the sixth one. Complete the congruence statements. These two triangles are given here. Let me draw them. B, T, A, and this is C. Observing the symbols in these two triangles, B, A, T. This is the triangle BAT, and one more triangle ACB, right angled at A and A. This B angle is equal to this angle B, and this angle T is equal to this angle C. Therefore, vertex B corresponds to vertex B, vertex T corresponds to vertex C, and vertex A corresponds to vertex A. Our answer should be triangle BCA is congruent to B, corresponds to B, C corresponds to T, A corresponds to A, BTA. This is how you should be able to write the congruent triangles like this. This is triangle BTA. Now the seventh one. Next figure. This is the first figure given. Let me draw the second figure. Yes, P, T. This angle is equal to this angle, see. And this angle is equal to this angle. And this angle is equal to this angle. What about the sides? This side PQ is equal to RS, and PT is equal to QR. TQ is equal to QS. In these two triangles, let me draw the figures separately. P, Q, T, Q, R, S. This angle is equal to this angle here. And this angle is equal to this angle here. And this angle is equal to this angle. And the sides PT is equal to QR. TQ is equal to SQ. QP is equal to RS. Therefore, P corresponds to this angle is equal to R here, R. And T corresponds to this angle is equal to Q here. These two triangles, see, triangle 1, triangle 2. This is first triangle, this is second triangle. In the first triangle, this is first triangle, this is the second triangle. This is first triangle, this is second triangle. In first triangle, the other vertex P, T, Q. Q corresponds to, in the second triangle, Q corresponds to angle S. Don't get confused. Here, accordingly, you have to write the corresponding vertices. Angle P is equal to angle R here. Therefore, P corresponds to R. Angle T is equal to angle Q in this triangle. In the triangle 2, number 2. And angle Q in this first triangle, this one. Q is equal to angle S in the second triangle. Therefore, these vertices are equal correspondingly. We can write triangle QRS. QRS is congruent to triangle Q. First triangle, you have to consider the first triangle. Q corresponds to S in the second triangle and R in the first triangle. QRS. Oh, this is second triangle. QRS is second triangle. QRS. In the second triangle, Q corresponds to T. This is wrong. Triangle QRS correspond to triangle QRS is the second one. Here, that in the textbook, the question is given in such a way that you should not be confused in writing the congruent triangles symbolically. QRS is the second triangle here. QRS. QRS is the second triangle. And in second triangle, Q corresponds to T. Triangle T. In second triangle, R corresponds to P. In second triangle, S corresponds to Q. So, your answer should be triangle QRS is congruent to triangle TPQ. This one is wrong because QRS is the second triangle. Did you understand? If you have any confusion, please ask me in the comment box. I will answer. Okay. Always the correspondence of the parts is important. Here the second triangle QRS is given in the question. Triangle QRS. This is second triangle. Second triangle vertex Q corresponds to vertex T in the first triangle. First write the corresponding parts, then write the triangles symbolically. Now the seventh one. It reads, in a squared sheet, draw two triangles of equal areas such that the seventh one. This is the sixth one we completed, right? Yes. Now the seventh one. In a squared sheet, there is a square sheet. Draw two triangles of equal areas such that the triangles are congruent. Here, in these two triangles, let us take the midpoint of the given side A, B, C, D and join that midpoint to the other vertices of the square. Square sheet means we'll draw A, B, C, D as one square and E be the midpoint of DC. Do you remember what are the properties of a square? All the sides are equal and all the angles are 90 degree. Therefore, this angle D is equal to 90 degree and angle C is equal to 90 degree. Let E be the midpoint of the side DC. Then DE is equal to EC and AD is equal to BC because ABCD is a square and angle D is equal to angle C is equal to 90 degree. The same reason ABCD is a square. In two triangles ADE and BCE, AD is height of triangle ADE and DE is the base. Therefore, area of triangle ADE is equal to half into base into height DE into AD. Here base is DE and height is AD. And we know that DE is equal to EC into AD is BC. This is equal to area of triangle BCE. Is it not? Because area of triangle BCE in triangle BCE, BC is equal to height and EC is equal to base of triangle BCE. Therefore, we have two triangles with equal areas. Now we see that these two triangles are similar. What is the first question? The triangles are congruent. We say that triangle ADE is congruent to triangle BCE. Why? Why they are congruent? In these two triangles, DE is equal to EC and BC is equal to AD because ABCD is a square and sides of the square are equal and this is the right angle equal to 90 degree. By SAS, these two sides and the included angle, these two sides and the included angle are equal. Therefore, by SAS congruency rule, these two triangles are congruent. Why? Because in triangles ADE and BCE, angle D is equal to angle C, AD is equal to BC, DE is equal to CE. See, angle D is equal to angle C, AD is equal to BC, DE is equal to CE. We have maintained the order. These two triangles are congruent by SAS criterion, triangle ADE is congruent to triangle BCE. This is how we should write. What about the second one? The triangles are not congruent. Now, we'll draw another figure. Let P, Q, R, S be a square sheet. Let us take any point, say T, on one side and draw PR the diagonal. Here we take in triangles PSR and TSR. The base is equal to SR for both triangles. Let me draw them separately. This is PSR, TSR, and this is the TU. This is U. They have equal areas. Why? Area of triangle PSR is equal to half into PS into SR, right? Base is SR, PS is height. But PS is equal to TU. Why? PS is the height of the square. TU is also the height of the square. Because these two are equal. Why they are equal? Sides are equal and the angles of all the angles of the square are equal to 90 degrees. Therefore, PS is the height of the triangle is equal to the height of the triangle TSR also. Because the reason should be PQRS is a square and SR is equal to SR is the base for two triangles. SR is equal to SR. In these two triangles, base is the same and height is also same. Therefore, area of triangle TSR is equal to half into TU into SR. This is equal to half into TU is equal to PS into SR. PS is SP, same. We say that area of triangle PSR is equal to area of triangle TSR. Now we have two triangles of equal areas. But do you think, are they congruent? They are not. Why? Here this is the right angle triangle and this is not. Being TU is the height, but triangle TSR, this whole triangle is not equal to this triangle. Not equal to means not congruent. Because this is the right angle triangle and this is not. We say that triangle PSR is not congruent to triangle PSR is not congruent to triangle TSR. So we have two triangles of equal areas which are not congruent. Now the next question. What is the next question? Eighth one. Draw a rough sketch of two triangles such that they have 5 pairs of congruent parts, but still the triangles are congruent. Let us draw. Here A, B, C, P, Q, R. Angle B is equal to angle Q, 90 degree. And AB is equal to QP. And this angle is equal to 30 degrees. And this angle is equal to 60 degrees. And this angle is equal to 30 degrees. And this angle is equal to 60 degrees. Here we have 3 angles and 2 sides. This side is equal to this side. We have 5 pairs of congruent parts. Angle B is equal to angle Q is equal to 90 degrees. Angle A is equal to angle R is equal to 30 degrees. Angle C is equal to angle P is equal to 60 degrees. AB is equal to QP. BC is equal to QR. Here, triangle ABC is not congruent to triangle PQR. Why? This question is helping you the importance of congruent parts, corresponding congruent parts, the importance of correspondence. You can argue by SAS rule or ASA rule. Can't we prove that they are congruent? No. We cannot prove that they are congruent because each vertex is not equal or correspondingly each vertex does not correspond to each other. These two triangles are not congruent. Now the ninth one. In triangle ABC and PQR, A, B, C and P, Q, R. If these are to be congruent, name one additional pair of corresponding parts. What criterion did you see? In these two triangles, angle B is equal to angle Q and angle C is equal to angle R. If BC is equal to RQ, if BC is equal to RQ, we can use ASA criterion to say that ABC is congruent to PQR. Now the 10th one. Explain why triangle ABC is congruent to triangle FED. The figures are like this: A, B, C. D, E, F. Observe here. The symbols here indicates that angle B is equal to angle E. Angle B is equal to angle E. BC is equal to ED. BC is equal to ED, and angle A is equal to angle F. Here triangle ABC, triangle FED. In these two triangles, two angles are equal. By angle sum property, the third angle is also equal. We should write in triangle ABC and triangle DEF, angle C is equal to angle D by angle sum property. Therefore, by ASA criterion, angle B is equal to angle E, angle C is equal to angle D, BC is equal to EF. Therefore, triangle ABC is congruent to triangle FED. Triangle ABC. BC is equal to ED. BC is equal to ED. BC corresponds to ED and B corresponds to E and C corresponds to F. ABC is congruent to FED. Hence, proved. Let us continue with some examples so that by practice you will be perfect in congruency of triangles.